Okay, so question 4 asks us to find the size of angle alpha. So that's angle alpha there. They've given us this lovely right angle triangle. I've just copied it down pretty roughly. It says to find the size of angle alpha correct to the nearest minute. And we know we're working with an angle and some sides in a right angle triangle. So we're going to be using one of the trig ratios. Which one are we going to use? We like to write it out like this so we can guess which one we need to use. This is our angle here, our given angle. So which sides do we have? Well, this is the hypotenuse here because it's opposite the right angle. So we know we've got the hypotenuse. And this side over here, is this opposite our angle or is it adjacent to our angle? It's opposite. It's not next to our angle, it's directly opposite our angle on the other side of the triangle. So we've got our opposite side here and our hypotenuse here. So we've got opposite and hypotenuse. Which of these ratios are we going to use? Opposite and hypotenuse, that's this SO ratio over here, which is the sine ratio. We can't use these two because they need the adjacent side, and we're not really interested in the adjacent side, that's over here. So we write out this ratio. This is the one that we're using, the sine ratio, and that basically means sine of an angle is equal to opposite over hypotenuse. Now in this case, our angle is, it's not theta, it's alpha. So let's plug all our values in now. We've got sine and our angle is alpha. Our opposite is 5.2 and our hypotenuse is 8.7. So we plug all our values into our equation and we end up with this equation here, which is lovely because we've only got one unknown, which is what we need to solve for. And at the moment, this alpha, this is what we want to get by itself isolated on the left-hand side. At the moment, it's tied up with this sine function. So we need to undo the sine function. We need to use the inverse operation like we would with any other operational function in an equation. And the inverse of sine we learnt is inverse sine, or looks like this. So that's a button on our calculator that we can use. We need to do this to both sides of the equation to keep it balanced. So we're doing it to the left-hand side here. That's the left-hand side. And we also need to do it to the right-hand side. And this is the right-hand side, 5.2 over 8.7. I just like to put brackets to show that we're doing it to the entire left-hand side and we're doing it to the entire right-hand side. Okay, so we performed the inverse sine on sine, so that basically got rid of sine. That's the inverse operation, so it undoes it. Oh, it undoes it. Now we're just left with the angle, which is what we wanted because that's what we're trying to find. We're trying to find the size of angle alpha. And we just need to do this expression on the calculator. We know this is a button on the calculator. All we need to do is press shift and then the sine button and we get our inverse sine there. And in brackets, we've got 5.2 over 8.7. Put that bracket on properly. And we need to make sure our calculator's in degrees mode, by the way, not radians. So make sure you've got a little D up there. Press equals, and this is the size of our angle. But this is as a decimal, and the question asks us to find the angle correct to the nearest minute. So when we're working with angles, we like to use this degrees, minutes and seconds button here. Sorry, is that on the screen? So we can press that to change it into degrees, minutes and seconds. And if we wanted to round this to the nearest minute, well, these are degrees, these are minutes. This is the minutes column here. And we need to look at the seconds to decide whether or not we round up or down. So 19 is less than 30. 19 is less than halfway, so we round down. So 42 minutes. We don't go up to 43. So that's our answer.